Hello and welcome to part 2 of our second lesson in Unit 6, Exponent Laws in our grade 11 University College math class. So we started this lesson on integer exponents by looking at a base to the exponent of 0. Now we're going to be looking at powers with negative exponents, so a base with a negative exponent. So proof of concept again, we're going to work through it. This time we're actually going to write it out ourselves. So we're going to use the exponent law first. That's what part little I there is telling us to do. So use the exponent law to subtract the exponents since they're being divided. So that's going to give us 2 to the exponent 2 minus 5, which gives us 2 to the exponent negative 3. Okay, so there's our first negative exponent. Don't really know what to do with that. To get a clue as to how negative exponents work, we're going to do part II, or two little i's, which is expand the powers and reduce the expression. So that's going to be 2 squared. So that's going to equal 2 times 2 all over 2 times 2 times 2 times 2 times 2. So there's our 5 2's. And as before, when we talk about reducing, we're dividing both the numerator and the denominator by the same number. So if we divide both numerator and denominator by 2, we effectively reduce 2 of the 2's, one from the numerator and one from the denominator. Let's divide numerator and denominator by 2 again. And we are now out of 2's in our numerator. So when we work this out, we end up with 1 over 2 times 2 times 2, which is 2 cubed. And some students, when we do this, normally point out, or often point out, that that's going to be 1 over 8. Okay, doing all right so far. Already I'm seeing a pattern here where 2 to the exponent negative 3 is an equivalent value to 1 over 2 to the exponent positive 3. And if we were to type this into our calculator, let me grab a calculator now. So I'm going to, let's set it up here first. So now we're going to type this into the calculator and see what we get. So that's going to be 2 squared divided by 2 to the exponent 5. And that's going to give us, let's ask the old calci here. So 2 to the exponent 2 divided by 2 to the exponent 5. And that's going to equal 0.125. Now there's usually one student out there, somebody, who recognizes that when you divide 1 by 8, when you actually do 1 divided by 8, that's going to equal 0.125. Let's make a prettier 0 there. So numerically, we have two values that are equal to each other. We ended up with 1 over 8 when we just reduced our fractions, and we had 0.125 when we actually do that division. The other patterning piece is that 2 to the exponent negative 3 is equal to 1 over 2 to the exponent positive 3. So the patterning for us when we're dealing with negative exponents is that we need to do something with our base. So if we have, as we can see here, b to the exponent negative n, that is the equivalent of 1 over b to the exponent positive n. So the same exponent becomes positive when you move it from, and I'll just draw this in, when you move it from the numerator down to the denominator. And that process is called inverting. When you invert your base, you end up with the same exponent but with the opposite sign. So it goes from a negative to a positive. So that's fine and dandy when we have a base with a single number. Here's an extension of it where we have a base that has two parts. So if we have a over b to the exponent negative n, it will be equal to that same inversion. Whoops, I guess the inversion would be over here. We would invert this to end up with b over a to the positive version of the same exponent. So inverting the base, that's what it's all about. Another mathy word for that is reciprocal. And it really just means, it's just a mathy way of saying like flip it upside down. So to tackle, I guess, processing a negative exponent, if we're asked to evaluate it or if we're being asked to simplify it, one way for us to do that is to invert our bases. Whether it is, as you see up in our first sort of summary point, if it's just a single base, or sorry, not a single base, but like a base over 1. And in our second example, when you have a rational base, a base that has a fraction, a numerator and a denominator. So those are our two sort of scenarios. Let's work through a couple of examples here. So again, we're being asked to do the twofer here. We're being asked to both simplify and evaluate. So that's a two-stepper. I'm not going to do a whole lot of highlighting of the orange and green variety this time. I'm going to sort of let that just ride, but rest assured I will be doing both sort of simultaneously. I'm going to be simplifying and then evaluate, and I'll certainly be talking through it. So let's get our first example. So we have 5 to the exponent 4 times 5 to the exponent negative 5. So we're multiplying these powers with the same base. So we are going to keep the base and we are going to add the exponents. So that's 4 plus negative 5. So that's going to give us 5 to the exponent negative 1. Now here's a negative exponent. When we're being asked to simplify, we can't leave it in this form. We're being asked to put it into a form where our exponent is positive. How do we do that? Well, this is sort of a tricky little 5 over 1. So the way to express this as a positive exponent is to invert our base. So that would be, instead of 5 over 1, 1 over 5, and that will be to the exponent positive 1. So that is simplified, and now we go on to evaluate it. Fortunately, there's not really any math to do there. It's just going to be 1 over 5. So that's our first example. Hopefully that makes some sense. Let's go have a look at the second. So you have 3 to the exponent 4 divided by 3 to the exponent 7. So we are dividing powers with the same base. We're going to keep the base and subtract the exponents. That's going to give us 3 to the exponent negative 3. Okay, so here, another negative exponent. We need to remedy that in order to be properly simplified. So remember, that's a 3 over 1. In order to deal with that negative exponent, we are going to invert the base, which is going to give us 1 over 3 to the same exponent positive. Okay, so this is simplified. Now we're going to evaluate. So evaluating means 1 cubed over 3 cubed. And if we do that, that's 1 times 1 times 1, which is 1, and 3 times 3 times 3, which is 27. So there is our second. Maybe I'll do a little bit of highlighting. I said I wouldn't. I'm going to do a little bit. This is simplified right here, positive exponent, and this is evaluated down here. Okay, got a couple more here. Let's work through. So this one has, again, same concept, just more steps now. So if we have 4 to the exponent negative 2 to the exponent 3, that's going to give us 4 to the exponent negative 6 times 4 to the exponent 5 all over 4 squared. Let's continue to simplify our numerator. That's going to give us 4 to the exponent. So we're multiplying these powers here with the same base. We're going to keep the base and add the exponents. That's going to give us negative 1 over 4 to the exponent 2. So now, I'm going to have to do some parallel work here. It's all right. So now we're dividing powers with the same base. We're going to keep the base, and we are going to subtract the exponents. So that's going to be negative 1 minus positive 2, which is going to give us 4 to the exponent negative 3. All right, so let's do a little bit of horizontal work here. So there we are. 4 to the exponent negative 3 has a negative exponent. We are going to, remember this is a 4 over 1, so in order to remedy that or address that negative exponent, we are going to invert the base, and now we have the positive version of that exponent. And when we evaluate that, that's 1 cubed over 4 cubed, and that's going to give us 1 times 1 times 1, which is 1, and 4 times 4, which is 16, times 4 is 64. So there we have our third example. Fourth example, a little more straightforward. This one actually has a rational base already. So to deal with that negative exponent, we are going to invert the base. So it's going to become, instead of 3 over 5, 5 over 3 to the exponent positive 2. So that now is simplified. It's got a single base and a positive exponent, and now we're going to evaluate. So that's going to give us 5 squared over 3 squared, and that will give us 25 over 9. And that has been evaluated. So there are our first 4 examples working through negative exponents. We're going to do a few at the bottom here, and again, practically speaking, you'd never really do this in the real world, I don't think, but we're just going to work this backwards. So we're going to take something here that we have 1 over 25, and we're going to work this backwards to something that has a negative exponent at the end. So the first step here is to find a way of expressing the denominator as a power. So 25 could be 25 to the exponent 1, but it could also be 5 to the exponent 2. And I want you to pick the smallest base possible here. So that's 5 to the exponent 2. As I said, if we wanted to turn 5 squared into a negative exponent, we would just have to invert the base again. It works the same way. It changes the sign when you invert the base, no matter what it is. We typically go from negative to positive. Here, by inverting the base, we are going to go from positive to negative. Totally fine. No problem at all. Okay, let's look at part B. Or example B. So 1 over 16. Now typically students will say, oh, that's going to be 1 over 4 squared. It is also 1 over 2 to the exponent 4. I would take either one of these. So in order to make these the exponent 2 in the first side and the exponent 4 in the second side, what we need to do is invert our bases. That changes the sign of our exponent. So when we invert our base, we end up with 4 to the exponent negative 2. And when we invert the second one, we end up with 2 to the exponent negative 4. So there's our second example. Third example, and this one takes there's a little trick to this. Anytime you're working with multiples of 10, sort of a little hack here to remember is that if I wanted to express 1,000 as a base 10, all I need to do is count up the zeros. So if I have 1, 2, 3 zeros, that's going to be 10 to the exponent 3. And now in order to express that as a negative exponent, I invert the base, which gives us, instead of 1 over 10, 10 over 1, and our positive exponent becomes negative. And there you go. That's the third example. Fourth example, this one's a decimal and it's gross. So can we figure out how to turn this into a fraction? Because that we can do. We can by counting our place values here. So this is going to be tenths, hundredths, thousandths, 10,000ths, 100,000ths. So that's going to actually be 1 over 100,000. Now remembering that little hack I taught you in the question or in the example before this, if we were going to express that as 10 to the exponent something, we just got to count up our zeros. So that's 1, 2, 3, 4, 5 zeros, which is going to give us 10 to the exponent 5. And to express that as a negative exponent, we invert the base again. Remember, inverting the base changes the sign of your exponent. It doesn't always go from negative to positive. If you're inverting the base, it can go from, as in this case, positive to negative. So that's going to give us 10 over 1 to the exponent negative 5. And those final examples take us to the end of lesson number 2 in our short unit on exponent laws. So get through that homework, come on back, and we'll see you for lesson number 3.